guys, we're going to do this gizmo on phase changes. So we're going to look at molecules and what happens to them when they turn into a solid or when they turn into a liquid or when they turn into a gas. We know that particles as a solid move slower than particles, or they just vibrate in place, than particles as a liquid, which move more freely and move faster. And then as a gas, they move pretty fast and much farther apart. But we're going to look at the actual phase change situation. Okay, what happens to temperature during phase change, what happens to molecules during phase change, and all that stuff. Okay, all right, so in our gizmo, we'll launch it and we're going to select micro view and we're going to set the ice volume to 50 centimeters. So we want some ice in there. And we see that we have some nitrogen, we have some oxygen, and then we have our water molecules. Here it is as water vapor, and here it is as water. And then we also have some ice right there. All right, so it says to click play and observe the water molecules in our solid, our liquid, and our gas. And we have to decide which phase our molecules held tightly together in a rigid way, kind of in a pattern. Is that the solid, the liquid, or the gas? And which phases do the molecules move freely? Okay. And number 3, which phases are the molecules held in a defined shape? So they make some sort of shape is what we're looking for in number 3. And then which phases do the molecules take the shape of their container? So we'll hit play and we'll take a look at all of that. All right. Molecules are held rigidly together in which phase? Solid, liquid, or gas? Which phases do the molecules move freely? Solid, liquid, or gas? You could choose more than one phase for number 2. In number 3, which phases are the molecules held in a defined shape? So which phase, solid, liquid, or gas, do we see molecules making some sort of shape? And then number 4, which phases do the molecules take the shape of their container? All right, that's the warm-up. Now it says to click reset and to select micro or macro view. So activity A, we're going to take a look at the macro view, so not the molecules. We'll set the water temperature to 10 and our ice volume to 0. There we go. And our ice, to 0, water temperature to 10. So I think we're all set. How is temperature related to phase change? So what happens to temperature when it freezes? What happens to temperature when ice melts? What happens to temperature when water becomes a gas? We kind of talked about that yesterday when we went over our summary page. But we'll take a look at it here. So letter A, at what temperature will water change from a liquid to a solid? So let's hit play. So we can see liquid water here, and we're predicting. Okay, so letter A, what temperature do you think water will change from a liquid to a solid? So what's the freezing point of water? What temperature will water change from a solid to a liquid? What's the melting point of water? And what temperature will water change from a liquid to a gas? What's boiling point? So make your predictions here. Now we're going to investigate and see if our predictions are accurate. So we're going to add and remove energy. So we're going to use this slider right there to control the water temperature. And we'll record our observations here. So we'll record the temperatures and then some observations. Okay, so we're going to hit play. And I'm going to remove energy because we want to take a look at what temperature does water freeze, the freezing point. So we'll remove energy. And we can see that water is freezing right now at 0 degrees. What do we notice about the temperature while the water is in the freezing process? We notice that the temperature stayed the same. So we'll look at that again. So it's freezing right now and the temperature is staying the same. So that's your number 3. Temperature stays the same. Okay, so let's reset it. Now we're going to do the melting point. So now that let's get it back to ice. So we'll get it back to ice, and then we'll look at melting. I'm going to add energy. Once all this water turns to ice, I'm going to add energy to look at the melting point. Now that it's all ice, we can see water temperature dropping, but now I'm going to add energy for letter B. Okay, we're adding energy, and at 100 degrees, nope, that's minus 100. Let's go more. There we go. Let's go. Wow. Okay, try it again. All right, so we're adding energy, and we can see that the temperature is going back up. This is all ice right now. We can see the phase change occur. We can see water right here at the bottom. It is 0 degrees Celsius. So our ice is melting right now. Let's see if we can get that going a little faster. And it is melting at 0 degrees Celsius. So that's your letter B, 0 degrees Celsius. And we notice that the temperature is not changing. So this is your number 4. So while ice is melting, temperature does not change. So let's see if temperature changes during evaporation. All right, now that it's all water, we're going to add more energy to see if we can get this to boil. So we want to do our letter C. At what temperature does water boil? Well, we do see that the temperature is increasing. We don't have boiling yet. All right, we start to see some bubbles, so that's boiling. And that happened at 100 degrees Celsius. And we notice that during evaporation, the temperature is not changing. So both number 3 and number 4, we notice that temperature does not change. Okay, now we're going to select graph, and we're going to hit this minus sign so we can look at our whole graph there. Okay, so while this was occurring, so we did freezing, so our line is straight, because we're going to do number 5. What does the graph look like during a phase change? Straight. This is melting, straight line, meaning there is no change over time during the phase change. So it is a straight line. Number 5, it is a straight line. That's what the graph looks like during the phase change. So why do we think temperature does not change during a phase change? So what is the theory there? Okay, we talked yesterday about energy being used. So energy is being used. So this is our number 6. Energy is being used to break the bonds. Energy is being used to cause molecules to move faster. So while energy is being used, we aren't measuring any energy. Okay, it's being used. Okay. All right, so let's see why phase changes occur. So then we're going to set the water temperature to 0. So first of all, we'll click reset. We got to get it all set up. We'll set it to micro view. Okay, now we see the particles. We want to set ice volume to 0. Okay, so we're back down to 0. And we want to set our energy to 0. So we'll go right in the middle there. All right. Okay. So we have it set in the way that it wants us to set it. Okay. The question is, why do phase changes occur? We've set our water temperature to 0, and we'll click play, and we're going to observe the water molecules. Then we'll click reset. We'll set the water temperature to 100 degrees. We'll click play again, and then we'll type in, what did we notice? All right, so clicking play. going to observe water molecules. We notice that water molecules are moving freely, bouncing around, colliding into one another. And now we're going to set the water temperature to 100 degrees. Okay, water temperature to 100. And then observe again. All right, so they are moving freely. Okay. All right. So we notice that water molecules can move freely. Did we notice them moving faster? So I'll set the water temperature to 0. Oh, 0. Okay. Again. All right, yeah, they are moving a little bit slower at 0, aren't they? And then when I move it to 100 degrees, oh, there they speed up. They move faster. So molecules are moving faster when we added energy and increased the temperature. All right, it says to click reset. We want to take a look at average speed. So it says the mean molecular speed. That's average speed. So we're going to see that down here, okay? And we're going to set the water temperature to 0. Okay, and we're going to add and remove heat energy to 400. So we'll add energy in this case. 400. Oh, come on. Good enough. We'll click play. And what happens to the speed of the particles? Well, we can see them increasing. Now, how does that relate to temperature? We can see that the temperature is going up as speed goes up. So does the average speed change as much as the temperature as the water heats up? Yeah, we can see that as the molecules speed up, the temperature increases. And that is how they are related. Temperature increases as molecules speed up. Okay, we'll hit reset. We're going to set the water temperature to 20, ice volume to 50, and we're going to go back down to 0. Whoops, joules. Okay, we'll click play. How do the molecules in the liquid interact with the molecules in the solid? Well, we can see that they're kind of colliding, aren't they? They're colliding into the ice molecules, the solid molecules, and they're causing the solid molecules to break their bonds. And that causes that ice to become water. So those bonds break, the solid molecules become free, and they join the water. Now we'll click reset, and we'll set the temperature to 100. Ice volume's at 50. And now we're going to compare the situation. We have a higher temperature. Oh, now it's just happening faster. So the molecules are colliding at a much quicker rate. The ice melts at a much quicker rate. Okay. All right. So based on what we've observed, explain why we think phase changes occur. So we can say that phase changes occur because of energy. So energy is causing particles to move faster, collide into one another, break bonds, move more freely, all because of added energy. Or even a decrease of energy. Decreasing energy causes molecules to slow down, create bonds, become solid. So number 6 is energy, everything about energy. All right, number 7, use your theory to explain what happens at the molecular level in each of the following situations. And then we'll list the temperature at which this occurs. So ice is warmed to the melting point. So we'll hit play, and I'm going to remove energy. Nope. Well, yeah, we'll create some ice. So we want ice to occur here so we can answer letter A. Okay, so we have ice, and now we're gonna warm up our container. Warming up the ice, we can see temperatures rising. So what's going on in the molecular level? What do we see happening? Right now they're just vibrating in place as ice, but we can see the temperature is increasing. Oh, there they go. So at 0 degrees Celsius, so that's our temperature here for letter A, we can see molecules. So we want to describe molecules are moving much faster, breaking bonds and moving more freely. Okay, letter B, water is warmed to the boiling point. We see temperature increasing. It's not boiling yet. We don't see that yet, but temperature is increasing. Okay, we're getting up there. Boiling is at 100 degrees. We see boiling. We see molecules breaking free and becoming gas. We can see that they are rising up into the air, moving much faster, boiling. Oh, there they go. Yep, becoming gas. So now they're starting to break free and become gas at 100 degrees Celsius. Okay, letter C, water is cooled to the freezing point. So let's cool it back down. And what are we seeing happening once we get down to freezing point? We're going to take a look at the molecules and describe what's happening to the molecules. All right, we can see that they slow down, they become locked in place, they vibrate in place because they're a solid. And that happened at 0 degrees. So 0 degrees for letter C. All right, last one is we're going to click reset. We're going to set the water temperature to 0. The ice volume to 0, so we don't want any ice. We're going to add and remove energy. So we'll be going to 400, removing some energy. Oh, come on. There we go. Okay. We'll click play until all water freezes. Okay. We can see that our ice is increasing in volume. So letter A, what volume of ice is created from 200 centimeters of water? 217 centimeters of ice. So we gained volume. We gained 17 cubic centimeters in volume. So ice takes up more space than water. So why do water pipes sometimes burst in the winter? So if there's water in the pipes and ice takes up more space, and so that water freezes, it's going to, create some breakage. That those pipes are going to break. All right, that's it. Hopefully that helped. Let me know if you have any questions.